All right. So yesterday, all right, so yesterday, Top Hat apparently was having some issues late afternoon. I kind of panicked and sent out some announcements because I thought maybe I'd forgotten to tell you guys to do something. I was correct. My original assumption is you guys have already kind of paid for it by belonging to Kelly or belonging to the university. So it might have prompted you to pay for it or create a free trial. You shouldn't have. I got an email that across the different sections were in 20 students. So if there were a handful of you that actually signed up for that free trial, they're kind of working on resolving that issue. But you still should all have access to it. But just in case anyone kind of ran into some issues yesterday, I extended the due date to be the end of the day today on those class questions. Everything should be working from like kind of late, not late, but like 7, 8 o'clock last night on. But there was kind of that brief downtime. Okay, so I want to make sure I mention that. You will still have a Module 9 quiz that's due at the end of the day, Monday. And then we also have that third hackback, which is kind of assigned early this week. Kind of over this next week, I told you going to make sure you get it done early. So you don't have to worry about it. So you can start studying for next week's exam. All right. So a week from today in this classroom, we will have the second exam. That practice exam has been up there, right? So I had some people stop by my office yesterday, ask a couple of questions. People have already started looking at it. I would try to start looking at that early. Just kind of like last time, most of Tuesday's class will be review. There's probably going to be a little bit of material you don't quite have enough time to cover for Module 9 today. It shouldn't take us more than 5-10 minutes to work through some problems even related to that on Tuesday's class. So it'll be basically like a review session on Tuesday. You know, I have another class, which is called econometrics, but basically have a couple sections of it. And I run these fancy things called regressions, which is basically data analysis that proves some of what I'm saying. So I ran a regression, and basically attendance in the review session before the exam in that class increased performance by 9 points. That's almost an entire letter grade. I imagine if I were to somehow be able to collect attendance, I'd find a pretty similar thing in this class, right? So I can't stress enough attending that review session. Also, next Wednesday's office hours, I have a room. I'll get an announcement up about where it's at instead of my usual office to accommodate more people. I've got a room reserved over in Wiley. I think it's instead of my office, it's on the first floor. So same building. First floor. So I'll just be working through more, answering people's questions, working through a lot more problems there. That's also something I think is highly beneficial to attend if you're able to. Okay. More on that, I'll mention again on next Tuesday, but just kind of getting that out of the way here as well. I'm just kind of mentioning it now. So that's kind of where we're at. Any questions for me before we kind of jump into material here today? Okay. To make sure I'm recording this. Okay. So we left off talking about this relationship between marginal productivity of labor and average productivity of labor, right? So we said if the marginal product, what I'm adding, is above the old average, my new average has to be higher. We'll use this idea today, but we'll put it in the context of firm's cost. So we're going to start out with this example, and I'll kind of give you an idea about what's happening with marginal cost. Okay? So let's say I've got a number of workers, and it looks something like this. Right? And the total output, or the total quantity of the product that I'm getting, if I hire 0 workers, I'm getting nothing. First worker adds 100. I get a total output of 160 from the third. We said, how do we calculate kind of my marginal productivity of labor? Right? Well, I'm thinking about how much did that first worker add to my output? 100 units. How much did the second worker add? 60. How much did the third worker add? 40. Right? So we said, initially, we might see an uptick in marginal productivity because of what? Gains from, but over time, what happens? We get these diminishing returns, right? So if we then think about just output, so the product that we're making, and I think about what would my total costs be. Okay. Now, in this example, I've assumed away any fixed costs. We'll talk about those here in a second. I'm just paying labor, right? That's the only thing I need to produce whatever product I'm producing. So my total cost at a quantity of 0 would be not paying anyone. Let's assume that I can hire workers for $50. Maybe this is $50 an hour or whatever it ends up being. To get those first 100 units, how many workers do I need to hire? That first worker brings in how many additional units? 100. So how many workers do I need to hire? 1, right? My total cost would then be $50. Now, to get the next 100 units, to go from 100 to 200 units, how many workers did I have to hire? I needed 2. So my total cost here would be, well, I'm paying the first worker 50. I'm now paying 2 more workers. My total cost, I need 3 workers to get those 200 units of output. So anytime we're talking about marginal anything, total, so if I wanted the marginal productivity of labor, it was the change in my total output from a change in the number of workers. If I want marginal cost, that's going to be the change in my total cost from what? A change in the number of units I'm producing. So going from 0 to 100 units here, what was the change in my total cost? 50. What was the change in quantity? 100. So my marginal costs were 0.5. Now, to get that same additional 100 units, going from 0 to 100, 100 to 200, what was my change in total cost now? 100 divided by the change in the number of units of 100. What's happening to my marginal costs? They're increasing. We've said this before. That's what's represented by our supply chain. Why are marginal costs increasing? Essentially, it's directly related to what we talked about last class. Because I'm hiring less and less efficient workers, to get the same increase in output, I'm now going to need more workers, which means I'm going to have to pay more money. My marginal cost will be increasing as a direct result of the fact that my marginal productivity of labor is decreasing. Okay. Now, we'll see this in a more complicated form here in a second, but just kind of introducing that idea that the marginal product is directly related to my marginal costs. Now, I say directly related, they're actually inverse, right? When my marginal productivity of labor is decreasing, when I drew my arrow pointing here, but right, what's happening to my marginal costs? They were increasing. Okay. So let's look at this in a slightly different context. Right? So let's say I go back to my Chipotle example, right? And let's say that I'm paying every single worker $2,000 a month, and I have to rent this space, right? So I have to operate my business out of somewhere. I'm kind of locked into this rental agreement. Maybe I own it and I'm paying on the mortgage, same kind of idea, right? Doesn't matter how much I produce, right? So I think about, here's a bunch of different workers I could hire. Here's the different quantity or the number of burritos I could produce. That was my output. Right? What's the cost of the building going to be at every single quantity? $1,000. Doesn't matter how much I produce. So we introduced this idea kind of at the end of last class, the difference between short and kind of long run. We said in the long run, I can change anything. I can move to a new building. But in the short run, there are going to be some things that are fixed. So the cost of the building here, it doesn't depend on how much I'm producing. So we would say that would be our fixed cost. It doesn't change. It's always 1,000. Doesn't matter if I produce 1,000 units or 3,000 units. It's the same value. Okay. Now my labor, we said usually that's probably the most common thing we think of as a short run cost because I can hire and fire workers minute to minute, right? If I really want to. So my cost of labor to produce these additional units of output is going to be increasing, right? If I want to go from 1,000 to 1,800 units, I've got to hire that second worker. I've got to pay them that wage rate of $2,000. Now, what are my total costs here? My total costs are going to be whatever my short run costs are, plus my kind of long run costs, or those fixed costs, those things I can change in the long run. So our total cost would just be the cost of the building plus our labor costs. Right? That's all we're doing to get our total costs there. Nothing crazy. Okay? Now that we have these different levels of output, right? The product we're producing, burritos here, and we also have the total cost, we can then kind of plot those out and think about what is our total cost per looking at. Right? If I want to produce a different number of units, what is the total cost that's associated with producing each one of those different quantities? Okay. So what do you notice is true about this total cost curve? It is increasing. If I want to produce more, I'm going to have to hire more workers, buy more raw materials, buy more machinery, move to a larger building, all of these things, right? So my total costs will be increasing. However, if I think about my marginal costs, so this word of marginal means change. So marginal cost is my change in cost. So we're looking at a change in our total cost divided by that change in the number of units I want to produce. You can kind of think about it as if I'm producing an additional 10 units and my costs are going up by 200, kind of each additional unit was increasing my cost by $20, right? 200 over 10 there. So if we go back to that cost curve, I had my total costs, I had my quantities, I could calculate marginal cost pretty easily, right? So if I go back to those quantities and total costs, what would the marginal cost of those first 1,000 burritos be? Well, my total cost was going up by 2,000. My quantity was going up by 1,000. So the change in total cost over the change in quantity, that would have just been 2. Whoops, there we go. What about the next 800 burritos? What was my change in the total cost? Well, now costs are still going up by 2,000, right? But I'm only getting 100 additional units, or 800 additional units, right? So what is my marginal cost, the change in my total cost divided by a change in quantity? $2.50. I would then go through each one of these, calculate my marginal cost, and what I'll see is, oh yeah, sure enough, once we have diminishing returns to labor, what's happening to our marginal costs? They're increasing, right? Because in order to get more units, I have to hire more workers, and I'm hiring less and less efficient workers. So calculating marginal cost really shouldn't look a whole lot different than we were calculating marginal anything. Okay. Any questions on this? I'm going through this a little bit quick because I want to save some time for some other stuff. This shouldn't be, I don't think, too terribly bad yet. All right, so we've got this marginal cost curve. It's going to look something like this if we plotted it out. So I'm going to draw the connection just for some of you who are a little bit more maybe math-minded here. If I'm thinking about, I had different levels of output, right? My quantity. And I had my total cost. We said the total cost curve looks something like this, right? This is kind of representing my total costs. If I'm calculating marginal, so I'm looking at those same levels of output, but I want to calculate my marginal costs. So I don't know everyone's math background. If you hear this word marginal, the change in something from a change in something else, that sounds a lot like a. So if I have a function, and I'm thinking about it's a function of x, if I find the change in y and the change in x, that's taking a derivative, right? What does the derivative tell me? It tells me the slope of whatever that y value is. If I'm thinking about total cost, the change in total cost from a change in quantity, that's just the derivative. That's the slope of my total cost curve. So what's happening to the slope of my total cost curve? It's increasing, which is why we have increasing marginal costs. All that's measuring is the change in the slope of our total cost curve. How much are our costs changing by? So we know that when we want to produce more, our total costs will be going up, but not only are they increasing, they're increasing at an increasing rate, right? Those marginal costs are getting higher and higher. Okay. Any questions on that? I'm making the connection there. Okay. All right. So with this in mind, right, we're then going to think about what is the firm trying to do? Maybe we'll think about it. There we go. What is the firm trying to do? Right. So we talked about last class. They're trying to maximize what? Not accounting profits, but economic profits, right? So we're going to be thinking about how can they do that? Well, what's the marginal benefit to the firm? We've talked a little bit about their cost. What's what's the marginal benefit to the firm? When I sell something, marginal benefit to me is how much I'm selling it for, which is the price, right? So I can think about total revenue. What would essentially my marginal revenue be, or the marginal benefit to the firm? Well, every time I sell one more unit, how much additional money am I making? Whatever the price of the good is. So when we're thinking about these marginal costs, the optimal level will be, well, I know my costs are increasing. Initially, those marginal costs might be below the price, which is the marginal benefit to the firm. So as we're thinking about higher and higher levels of output, for all of these units, what's true? The marginal benefit to the firm is greater than the additional costs. So all of these units make sense for them to produce and sell. Now, as soon as we get to a point out here, what's now true? If I were to produce this quantity, the additional money I can make by selling it is less than the additional cost that it took me to produce it. So what will be happening to profits there? They're going down, right? There's like a net negative benefit here. The costs are greater than the benefits. So what would the optimal or kind of equilibrium, if you want to think about it that way, quantity for the firm be? Where that price is equal to their marginal cost. So here we're thinking about firms are going to start to make decisions just like consumers. We're going to choose to do something as a consumer as long as the marginal benefit is above the marginal cost. What is a firm going to do? We're going to choose not to consume something, but we're going to choose to produce it as long as that marginal benefit, the price, is above our marginal costs. Okay? Is something not clear? We're okay with this? Here. So what did this represent, right? If I was producing at quantities out here, what's true about the additional cost compared to the additional benefits? The additional costs are, so we said what's happening here, this would be decreasing my profits. I shouldn't say profits are negative here, but from that one unit, right, I'd be losing money. If it costs me $20 to make it and I can only sell it for 10, I lost money on that. So this range of quantities doesn't make any sense for the firm to produce, right? They would just be losing money at those quantities. Any other questions on this before we keep moving here? Okay, so basically what we're thinking about, if we're hiring these workers, eventually their marginal product translates to marginal cost. We're going to choose to hire more workers as long as the additional cost they bring to our company is lower than that price we can sell the good for. So we'll kind of break down our firm's costs into a couple other categories now. So we've got these marginal costs. We're also going to be focused on two different types of costs we've already kind of talked about. One is fixed, right? So fixed costs are things that we can't change in the short run. So this would be like, we're in the building that we're in right now. I could maybe move to a building next month or next year, but right now I've got to operate out of the space that I'm in. So anytime we have a fixed cost, this was like our rental cost, it is the same amount no matter what quantity we produce. Now our variable costs, if I produce nothing, how many people do I have to hire? 0, right? So my variable cost would be 0. So my total variable costs are completely dependent on how much I'm producing. If I want to produce more and more, what do I have to start doing? Hiring more and more workers. What's going to happen to my total variable costs? They're going to be getting higher and higher. So my total variable costs depend on my output. My fixed costs do not, right? Our total costs will just be the sum of those two things, right? We're going to just have two different categories there, fixed and variable costs, okay? Total cost being the sum of the two, okay? I don't think that's anything too crazy yet. So if we think about visually, if I had fixed costs, what's going to be true about that fixed cost column? Every single value is going to be exactly the same. Or if I graph it out visually, a horizontal line, right? So in this case, I just kind of chose this fixed cost of, let's say we had $100, right? at every quantity, my fixed cost is still $100. So what's going to be true about my, variable costs? As I produce a higher number of units here, what's happening to my variable costs? They're increasing, right? So I've got my total variable costs there, being that orange line, where they're going to be increasing. Now, notice there's this kind of weird jog here, right? Let's not worry too much about that yet, but where would that come from if you had to guess? That there's some gains from specialization early on. That's doing some weird things with our variable cost, where initially maybe they're not changing at the same rate as once diminishing returns to labor takes over. Now, if I wanted my total costs, what would I do at every single quantity? I would just take my total variable costs and add $100. Yep, my fixed costs. So I would just take my variable costs, add my fixed costs, and I could get this entire total cost column, right? So it's going to look something like this. My total costs in the short run, as long as I have some fixed costs, my total costs have to be greater than my variable costs, right? Because they are my variable costs plus fixed costs. So they would have to be higher, right? So as long as we're in the short run and we have any level of fixed costs, those total costs will be higher than our variable costs. Okay? Any questions on that before we keep moving here?
What would you say for like, is it the price change from 0 to 7 from like 2 to 50? Why do you say that way?
So yeah, if I wanted to calculate marginal costs, right? So you're jumping the gun here, but you're good. I can look at that total cost column, and the changes in my total cost divided by a change in quantity, you correctly identified. Initially, they're falling. So even if I don't have the marginal productivity of labor, if I have this marginal cost curve, and we just saw that for those like quantities, I think it was like 0 to 3, it looked like my marginal costs were decreasing. What has to be true about these quantities? My costs are decreasing. We said the marginal productivity of labor must be going up, or I've got gains from specialization. So I don't even need to see the marginal productivity of labor. If my marginal costs are decreasing, it must be that my workers, as I hire more, are becoming more and more efficient, or I'm having these gains from specialization. Now, once I get to the quantities past 3, we'll go back to the slides here in a second. There we saw our marginal costs were increasing from that point on. So for every quantity in this range, what has taken over are diminishing returns to labor. All right. So we will see our marginal costs look very different than our variable costs. Right? Is that what you were kind of getting at? Yeah. So with these marginal costs, right, we can kind of think about, we already talked about how we calculate them. I want to kind of get to the visual. There we go. They're going to look something like this, right? I always kind of sometimes reference like the Nike symbol, right? They initially decrease, and then eventually they take off. And the reason is because they're directly related to that marginal productivity of labor curve that we talked about last class. So kind of leading us to this a little bit, but if I calculated my marginal costs based off the total cost, what else could I calculate the marginal costs from? The exact same values. So if my fixed costs are never changing, what's the only thing that's changing my total costs? Or yeah, total costs. My variable costs. So I could actually calculate marginal costs using these variable costs as well. Notice what's the change in my total and variable costs here? 70. What's the change here? 50, 40. They will always line up, right? The only thing that's changing my total cost is the fact that my variable costs are changing. So I could use either one to calculate those marginal costs. Now, just to kind of keep it consistent across other examples, I generally like just use the total cost, right? Because when we start talking about like marginal revenue, we'll do change in total revenue divided by the change in quantity. So I usually reference it as total cost, but theoretically, technically, you can use those variable costs as well. Okay. So we've got this increasing marginal cost curve. Okay. We're now going to talk about moving away from just these totals to thinking about averages. Right? So if I have this big expense, which is like renting my building, if I'm thinking about the average fixed cost, all an average is taking the total and dividing it by the number of numbers you have. Well, in the context of our costs and output, our average fixed cost would just be taking our total fixed cost and dividing it by quantity. So to go to an average, all we're doing is taking whatever that cost is, in this case, fixed cost. So my total fixed cost, which is 100, and I'm dividing it by the quantity. That's going to give me the average. You can think about it this way. If I'm spending $100, but I'm producing 10 units, on average, how much of each unit is coming from that fixed cost? Got $100 fixed cost, 10 units. On average, each one is worth $10 of that fixed cost. That's all we're doing. So if fixed costs never change, but I'm producing more, what's happening to this fraction? The quantity is going up, so my denominator is larger. So as I produce more, what's always happening to my average fixed cost? Has to be decreasing. Essentially, I'm taking the same amount of money and I'm spreading it out over more units. So my average fixed cost, if I go ahead and calculate it, right? Total divided by quantity, 100. Total divided by quantity, 50. Total divided by quantity, 33. My average fixed costs, as I produce more and more, have to always be decreasing. I'm just taking that same lump sum of money and I'm spreading it out over more units. Any questions on that idea? Yeah. An example of, yeah, if I'm spending, so let's say I have bought this huge new production facility, right? If I only produce one unit and I spent $1 million, all of that $1 million is on one unit. If I produce 1 million units, on average, how much did each unit take of that fixed cost? $1 each, right? By producing more, that fixed cost, that lump sum doesn't change. So by producing more, all I'm doing is taking that same amount and I'm spreading it out across more units. Any other questions on this? So I think I got a visual here, right? Which is that our average fixed costs are just continuously decreasing as we produce more and more. Okay. Now, what about our variable costs? Those are going to be a little bit different, right? So when I'm looking at my variable costs here, using the same values as in the past however many slides, how would I find my average variable cost? I would just take my total variable costs and divide by the quantity I'm producing, right? How much on average does each unit kind of take of those variable costs? So if I have total variable costs at one unit of 70, well, if I'm only producing one unit on average, how much of my variable costs are spread across that one unit? All 70, right? But what if I, think about that second unit? Well, now my total variable costs are 120, but I'm producing 2 units. So on average, how much is each unit accounting for of that total variable cost? Half of it, or 60, right? And the next one, total variable costs are 160, but I'm now producing 3 units. On average, each unit, how much of that variable cost is it accounting for? 160 over 3, right? So all I'm doing to find these averages is taking that total of whatever type of cost I'm interested in, dividing it by the quantity I'm producing. Any questions on this idea? Yeah.
Aren't variable costs like mostly based on wages?
So primarily they'll be based on labor costs. Yeah.
So I don't understand, like, wouldn't you be paying people the same wages? Why isn't the average variable cost the same?
So quantity here is not the quantity of labor. We're talking about what we're producing. So quantity is the output. So this is the idea that to get that very first unit, maybe I only have to hire 1 worker. They were really effective. But to get that second unit, now I've got to hire like the next 3 workers. They're all a lot worse, right? And so as I want to have that same increase in output, each additional unit is now not going to take 1 worker. Now it might take 2 workers. Then it might take 3, then 4. So what's happening to my labor costs? Every additional unit, I'm paying more and more workers. My labor costs are going to be higher, which is why our variable costs are increasing. Yep. No, I get it's tricky, right? So here it's not the quantity of labor, it's the quantity of the product that we're producing. Yep. Yeah. So the short answer is no. What you know, I'll have these all together and make a little more sense once I have this next visual here a little bit. But what we know is that if average variable costs are decreasing, we could be on the portion of the curve where we have gains in specialization. We don't necessarily have to be. So remind me of this in just a little bit. It's a good question, right? Now, if my average variable costs are increasing, there I know I have to be on a diminishing portion. Yep. So we'll kind of get there here in just a second. So what's going to end up being true? Initially, what's happening to my average variable costs? As I produce more, they were decreasing. But then at a certain level of output, if I continue to produce more, now my average variable costs start to increase, right? So I kind of have this U shape, right? So what's going to be true about my total costs? They're really going to be driven by the fact that my variable costs look like this. My total costs, I could walk through the exact same thing. I would just take my average fixed plus my average variable. What I'll notice about my average total cost is they're also initially decreasing. And then at a certain quantity, they start to increase as well. Now, it's not the exact same quantity as where average variable costs start to increase. And we'll kind of have a visual depiction of this here in just a second. So our average total cost curve, just to kind of give a visual, will also be U-shaped, but it'll be a slightly different U-shape. Notice it starts off pretty steep because our average total, unlike our average variable, had what factored into it? Total costs were just our variable costs plus fixed costs. So what was happening with our fixed costs? They were initially dramatically declining, which is why when we go to our total cost, it's initially kind of decreasing faster than that variable cost was. But it'll still have this kind of U shape to it. So let's put all of this together. Right? And I think I can answer some of the questions that were asked. So we said, if I'm thinking about graphing these things out, and I'm going to leave off average fixed costs just for now. Right? So here was my average variable cost. We said it had this U shape to it, right? There was a certain quantity where it bottomed out, right? Or it got to a minimum point. What's the difference between my average variable and my average total cost? So we didn't quite say this, but if I'm thinking about my total costs are just my total variable plus my total fixed costs. If I divide everything by Q here, what happens to this equality? So to brush up on your math skills. If I divide both sides of an equation by the same value, the equality still holds. It doesn't matter. It doesn't change anything. So what does this equation now represent? My average total costs, my average variable costs, and my average fixed costs, right? So not only will my total cost be the sum of variable and fixed costs, but my average total will be the sum of my average variable and my average fixed. So if I'm thinking about these average variable costs, what's the difference between them and my average total cost? The only thing that gets added in extra is my average fixed cost, right? What's the difference between average total and average variable? Just my average fixed. So initially, if I'm drawing out this average total cost, for really low quantities, what's true about our average fixed cost? It's pretty high. So what's going to be true about the gap in between my average total and average variable costs? It's going to be relatively high. Now, as I produce more and more, what did we say was happening to that average fixed cost? It's getting closer and closer to zero, right? It's going down, right? So what should be true at higher quantities is the gap in between my average total and my average variable cost. That difference is decreasing, because what is that difference? It's just my average fixed cost. And I know that as I produce more, that average fixed cost is decreasing. So we kind of have these two cost curves, right? Almost exactly like what we talked about last class. My marginal costs, will they change my fixed costs at all? So if I'm producing more, we said our fixed costs are always the same. So my marginal costs are only ever going to impact my variable costs. But if they impact my variable costs, what do they have to also be impacting? Well, if average total is average variable plus something else, they're also impacting my average total. So if I think about I have an average, if I have an additional cost that I'm adding in, or I have my marginal cost, if my marginal cost is below the old average, what's true about my new average? So if I have an average of 10, I add in a number 0 to that set of numbers, my new average has to be lower. So anytime my marginal cost is below the old average, my new averages have to be lower. Same thing up here. My marginal cost is below my average total cost. My new average total cost will be lower. Now, eventually we know that marginal costs, after this gains from specialization, eventually diminishing returns will take over. Now, what ends up being true, and I try to draw this to scale, right, is as soon as my marginal cost is above my average variable, what should be happening to my new average variable cost? I'm adding a number that's higher than the old average, my new average should be. So what's happening past this point when marginal costs are greater than average variable? My average variable costs start to increase. What happens when the marginal cost gets above my average total costs? My new average total cost should be increasing. Right? So it's the same relationship that we talked about with average and marginal productivity of labor. Anytime I've got, well, I didn't save myself a lot of room, but anytime I have marginal costs being below either my average total or my average variable, my new average will be lower. Anytime I've got a scenario where the marginal costs are greater than the average, my new average is going to be higher. So what point will that marginal cost hit both of my average total and average variable cost curves at? Some on the side, I think. Yeah, their lowest points, or right at their minimum point. So our relationship between this marginal cost curve and our average total and average variable, we know that it's going to intersect them at their minimum point, right? That's just a byproduct of mathematics, right? Marginal is what we're adding in. We add in a value that's lower, the new average has to be smaller, decreasing. As soon as they're equal, well, there it's bottomed out. There's no change, right? But the average is 10. I add in another number of 10, the new average is 10, right? And then as soon as that marginal cost is above the old average, our new average is going to be getting higher and higher. Okay. Any questions on this graph before we kind of keep moving? Okay. So we'll keep moving. I've got them all here. I put the average fixed cost. This, I think there's a little bit too much going on, which is why I kind of like drew this out here, right? That's why I left off my average fixed cost. But you can kind of notice, what's the gap between my average total, this green curve, and my average variable cost? Well, initially it's very large because my average fixed cost is really high. At higher quantities, what's the gap in between my average total and average variable? Well, now my average fixed cost is relatively low, so that gap has kind of narrowed. So here's a bunch of our different cost equations that we've talked about. You know, it looks scary when you see them all out here, but really, these two are saying the same thing. My total costs are just my variable costs plus my fixed costs. That same thing holds, if I'm looking at the averages. How do I find these averages? It's always just take whatever type of cost I'm interested in. If I want average total cost, take total cost divided by quantity. If I want average fixed cost, take total fixed cost divided by quantity, right? So all those average calculations are done the exact same way. And then we have that marginal cost equation which was the change in our total cost from a change in output or a change in quantity. All right, so we're going to take all of these things and we're going to put them into practice in this table. Okay, so I'm going to try to draw this out for us. I think you guys can see it still up here. Perfect. So I'm going to do quantity. I need to be able to see this though. So did I start it out at 0? Yeah, so 0, 1, 2, 3, 4. I've got my total variable costs. I've got my total fixed costs. I've got my total costs. Average variable. No. Yes. Average fixed. Average total. Marginal cost. Okay. Now I was given a couple pieces of information here. So I knew this was 7. This was 720. This was 740. Average variable at 3 was 15. And then average total at 4, 202. Okay. And then here, I can't calculate averages because I can't divide by 0, right? And there's nothing to compare to before 0. So at that 0 point, we don't have any marginal or average values. So probably the easiest way to start solving a problem like this, if you're trying to fill this table out or to find missing gaps or missing pieces, at a quantity of 0, what are the only costs that I have? Fixed costs. So what are my total variable costs? If my total costs are 720 when I'm producing nothing, what are my total fixed costs? It's the only kind of costs I have, so 720. Once I find those fixed costs, what can I now do? Yeah, someone just ran their finger down. I can fill this entire column in because it doesn't matter how much I'm producing. My total fixed costs are always going to be that exact same value. Okay. So I don't know. Always start out thinking about how can I figure out what those fixed costs are. Usually that quantity of 0 is going to be pretty helpful, right? Because we know there all we have are fixed costs. So might be kind of first thing I would do. There we go. So the next thing, well, how can I find total costs here? If I know my total variable, I know my total fixed, what does my total cost have to be? Yeah, right? Just the sum of those two things. Now, that doesn't help me down here because I don't know, all I know are my fixed costs. Here though, if I know my total cost is 740, total fixed cost is 720, what does my total variable cost have to be? Yeah, so the second thing I might start out doing is kind of using the fact that you know your total costs are your total variable plus your total fixed. That should kind of help us fill in a certain amount of information as well. Now from here, I'm going to have to start backing things out using my average kind of equations. Now, if I've got the totals, these should hopefully be really easy to fill out. How would I find these averages? For this row, I would just take these numbers and divide by quantity of 1, right? These are my costs. What are the average costs? It's just take the cost and divide it by the quantity you're producing. Well, here, if I'm only producing 1 unit, everything is exactly the same. Now, at that quantity of 2, now how do I find my averages? I would have to take these costs and divide by the quantity of 2. So I get what? 10, 360, and 370. Right? So the next thing I would kind of do is use totals. I'm going to run out of room, but define averages. Right? Now from here, it gets a little bit trickier. Right? So if I wanted to find my total variable cost here, and I know my average variable cost, right? So I'm going to move this to the side just for a second, so I give myself a little bit of room. How do I calculate my average variable cost? That's just my total variable cost divided by quantity. So if I know the average variable cost at a quantity of 3 is 15, what do my total variable costs have to be? I've got one equation, one unknown, just a little bit of cross multiplication, and I would end up with my, what's that? Total variable cost of 45. Now that I've got my total variable, what's my total cost have to be? It's just the sum of these two things. So 765. Now that I have all my costs, how can I find my averages? Just take all of these costs and divide them by 3, right? So here's is going to be what? 720 over 3 is 240, if I'm doing math in my head correct. 765 divided by 3 is going to be what? Sheet. 255. Right. So I now have one more row left. If I know an average, I can always back out what the total is as long as I know the quantity. So at a quantity of 4, if my average is 202, what does my total cost have to be? Once again, multiply both sides by 4, and I would end up with a total cost of 808. What does my total variable cost have to be? Well, my total cost is my fixed plus my variable costs. So what would my total variable cost have to be here? Yeah, 88. Now I can find my averages. 88 divided by 4 is 22. 720 divided by 4 would be what? So that would be 20 minus 2. So, no, 180. Yeah, okay. I was gonna say. Mental math in my head is hard sometimes. So I just filled out everything except for one column, right? So all I was using there is this principal of fixed costs, this idea that I know that the total is always the variable plus the fixed, and then using my averages, right, to back out what those totals were, or vice versa. If I knew the totals, I could calculate averages. If I knew the average, I could back out what the total had to be. Any questions over anything yet? We still have one more thing to fill out here. Okay. So how do I calculate marginal costs? That's just going to be my change in total costs divided by change in quantity. Now here, I have quantity jumps of 1, so it makes my life a little bit easier, right? So I can use 2 columns to actually calculate these marginal costs. Now, the one that I've written out is probably, to be best practice, like most responsible to use, but we can use another one, and I'll point out in here in a second. So for that very first quantity, what was the change in total cost? What was the change in quantity? So my marginal cost was 7. What was the change in my total cost to get to that second unit? 13 divided by the change in quantity of 1. Here it's 25. Here it's what? 35, so 43. So in this example, do I have, what quantities would I have gains from specialization from? Someone's shaking their head. None of them. Are my marginal costs ever decreasing here? No, right? So here I would have an example where I only had diminishing returns to labor kind of taking over. Also, as long as I have this up here, I just remembered your question. When you asked me, when I have that decreasing portion of the average variable or average total cost curves, notice that's the only place where I could ever have gains from spec. As soon as I get to that diminishing returns portion, what's always true, as soon as I get to the portion on my average total average variable where they're increasing, what has to be true about my marginal costs are that diminishing returns labor is taking over. Now there's a weird area they won't like quiz/test you on, which would be like right here, where I still have my averages decreasing, even though diminishing returns to labor have taken over. And that's kind of like diminishing returns are trying to like catch up to, well, overshadow those gains from specialization that we already had. Yep. Now, what's also kind of interesting, so if we're thinking about our averages here, in this example, what's happening to my average variable and my average total cost? They are always. So what's happening to my average variable costs? They are always increasing. So are my average. Actually, hold on. Yeah, average total costs. Wait, where am I at? Oh, never mind. So my average variable costs here, what am I looking at? So what do I have? Got average total costs, average variable costs. Yeah, so I have this weird example that doesn't really line up with my visual because I took away that gains from specialization. Notice what's true about my average variable cost here. It's always increasing. So it was almost like we started way out here, right? Now there was still a portion of the average total costs that are still decreasing here. But if we take away all gains from specialization, it does get a little bit different, right? We don't end up seeing this left part of our average variable cost curve. Now, most of the examples I'll give you for like the exam or on the quiz, I'll probably incorporate some level, like some quantities where you have this gains from specialization, just so we make sure if you want to do the visual, we have these nice kind of U-shaped curves. But you can have with these very like simplistic models, very low quantities, you can have these scenarios where you actually only end up with like half of that U, so to speak. Don't worry too much about that. I'm not going to try to like trick you with that or anything like that. But if you're wondering, looking at these numbers, that can occur, right? If I don't have any gains from specialization, I can kind of start way over here. Okay. So we filled out this entire table. Any other questions on this before we keep moving? Yes, no? What if something changed? Okay. All right, so here was kind of that entire table that we just filled out. There it is, right? So we already really talked about this. Why is it U-shaped? This is the idea that initially our average fixed costs, right, are declining pretty rapidly. But eventually, the fact that we have this diminishing returns to labor and our variable costs are increasing, those eventually will kind of take over and we end up with this kind of nice U shape. Now, what we'll end up calling the efficient scale, I kind of already identified it earlier, but it would have been that minimum point on our average total cost curve. So we got to think about why would we call this the efficient scale for companies? If my average total cost is at its lowest point, what have you like maybe heard if you were, I don't know, how much you're in Kelly, so you probably have attended certain things and you hear this speak in your other classes. The lowest average total cost would be my lowest per unit cost, right? I'm spending the lowest amount per unit if I'm at that quantity, right? Well, if I'm thinking about running a company, does that sound like a good thing? Yeah, I'm paying the lowest amount possible per unit at that minimum point of my average total cost curve. So we'll talk more about profits and different types of markets after this next exam, but this is going to be a pretty important point for us, this minimum point on our average total cost curve. Okay. Now I already jumped the gun a little bit and we said, okay, how do we find that point? Well, that's going to be where marginal cost intersects our average total cost curve. At any point below that, we said when marginal cost is below our new average has to be lower. So our average total cost is falling there. That sounds like a good thing, right? As I'm increasing my production, what am I doing to my per unit costs or my average total cost? I am decreasing it. So there, ramping up production makes sense. I'm decreasing my per unit costs. However, if I were ever to go past this efficient scale point, well, now my marginal costs are above my average. So my new average has to be higher. If I continue to increase production past this quantity, what am I doing to my per unit costs? I'm just increasing them. Do I want to be spending more money per unit? No, right? So we want to be at that kind of minimum point where the marginal cost intersects our average total cost curve. Okay. All right. So that's kind of our point. Like I said, I jumped the gun a little bit earlier, but I think given what we were doing, kind of made sense to introduce it there. You can also see this kind of graphically, or sorry, graphically. We looked at it graphically. You can look at a table, right? So notice here, excuse me, anytime my marginal cost of producing the additional number of units, if it's greater than my old average, sorry, here it's less than my old average. So if it's less than my old average, what has to be true about my new average? It's a little bit lower. And then if my next marginal cost, it's still below my old average, so my new average will be a little bit lower. As soon as that marginal cost gets to be above the old average, what's true about our new average? It's now a little bit higher. So it'll play out if you look at this in table form as well. Probably won't do this as much if you look at kind of those practice problems in the practice exam, but you could, show this with new numbers and kind of this production schedule, so to speak, where we have different outputs and then the different costs. Okay. All right. So what I then want to focus on, we have plenty of time, so this is good. So we talked about total costs, variable costs. I'm now going to make it kind of seem obsolete, but it won't be once we get past this exam. We're going to dive into issues that exist in the short run, but not the long run. So if I want to look at my short run costs, here I've got my marginal costs, and it intersects both the average total and the average variable at their minimum point, right? This is something that we already drew earlier. If I were moving to long run costs, which of these cost curves kind of goes away? My fixed costs go away completely, which means my average total costs will be equal to, if fixed costs are 0, all my total costs are simply coming from variable costs. So in the long run, right, when we can change anything, right, we can change what building we're in, we can move to a different country if we want to do for our production process, we can change everything, nothing is fixed. Our long run cost curve, our average total is equal to our average variable. Now the same principles apply whenever the marginal cost is below the average. Our new average is going to be decreasing. Whenever that marginal cost is above our average, our new average has to be higher or increasing. And that marginal cost will still intersect our average total cost curve at its minimum point. It's just now the average total costs are also average variable costs. Actually becomes almost like a little bit easier. We don't have as many things to really worry about. Right? So long run, my fixed costs will be equal to, if I can change everything in the long run, my fixed costs are 0. There's no difference between my total cost and variable costs because I have no fixed costs anymore. Now, sometimes I'll get questions or pushback. How long is the long run? It depends. It's always company specific, market specific, right? The way that we think about the long run, whatever length of time it would take me to be able to change all factors of production, right? Whatever length of time it would take me so that I could change anything in my production process. So with this in mind, when we're moving to this long run average total cost curve, if you think about the short run, if I was a company that's growing, right? Maybe I start out, I don't know, I'm printing graphic t-shirts or screen pressing t-shirts in my mom's basement, right? I then want to increase my production. Maybe I rent a small space in a small town. Well, in the short run, whatever that, I didn't have, when I was just starting out the basement, that was my costs were whatever they were operating out of that basement. Once I moved to this smaller production facility, this small building, well, now my costs are whatever they are in my current environment. Well, if I want to ramp it up, I now buy this huge warehouse, right, out on the side of some interstate. Well, now I'm in a new short run average total cost curve. So I can make these changes. I can change these factors of production that I can only change in the long run. And essentially what that's going to do is it's going to move me to different short run average total cost curves. Whatever my current environment is, that's my short run average total cost curve. So here I'm thinking about 3 different scenarios. I could be in a small production facility or factory, a medium size or a large size, right? So initially starting out, if I want to start to increase my output for lower levels of quantity or lower output levels here, where are my lowest per unit costs? Well, notice at this quantity, my per unit costs are lowest in that small production facility. If I were in the medium production facility, my per unit costs are even higher. Kind of intuitively, why does that make sense? If I'm not producing very much, to move to a larger production facility, I now have just increased my fixed costs and I'm not producing that much. So it's not getting spread out over as many units. Now, as I produce more and more, once I kind of get past this QA, if I want to increase my production past this point, if I stay in that small factory, my per unit costs are going to be up here. If I move to that medium-sized facility, what's happening to my per unit costs? At these quantities, I can actually achieve lower per unit costs. So as I'm ramping up production, it makes more sense to pay more for these larger facilities because I can spread out that fixed cost over a higher number of units. And then if I want to continue to increase it, where are my lowest per unit costs for all of these quantities? Well, they're way up here for my large and small factory, down here for the medium size. But eventually I get to this point where if I want to go past QB for any quantity out here, where are my lowest per unit costs? Now they're going to be in that large facility. They'd be higher if I stayed in that medium-sized factory. Hold on to that thought. Yeah. So what would my long run average total cost curve look like? Well, as I want to increase quantity, we said for these quantities, it makes sense to be in the small factory. And then if I want to continue to increase, I should switch over to the medium-sized factory. If I want to continue to increase, I should switch over to the large factory. So it's kind of like that long run average total cost curve. It's not really the minimum of these, but it's going to be whatever factory size or whatever this long run factor of production I'm changing. I always want to be on the short run cost curve, the short run average total cost curve that provides me the lowest value or the lowest per unit costs. Now, to your point, if I'm making a decision about where would the optimal point to be here, where would the efficient quantity be in the long run? In the long run, which of these factories am I going to end up on? My medium-sized production, because that's where I can achieve my lowest per unit cost. Now, that gets a little bit different when we're talking about different markets, we'll factor in prices, things like that. But for the sake of what we're doing in this module, if we just want to think about how can we get to that lowest per unit cost in our long run average total cost curve, that's going to be choosing this medium-sized facility. Yep. Any other questions? Kind of keep moving here. So to be a little bit more continuous, really, it's not like we only have 3 factories we could choose from. If you want to make it truly like real world, I could choose production facilities of any different square footage. So it becomes like very continuous. So when we're thinking about our long run average total cost curve, it's kind of like if we were just choosing the lowest per unit costs, right? Out of all of these different short run average total cost curves we could choose, that line that kind of traced the bottom of them, where we were always going to be on the short run average total cost curve that gave us the lowest per unit cost, that would be our long run average total cost curve. Well, notice once we get to this point, does it look a whole lot different than our short run average total cost curve? No, right? So when we start drawing things out after this exam, and we're talking about different markets, our long short run average total cost curve, they're all going to have the same shape, right? They're going to have this nice kind of U shape for us. Now, with the long run average total cost curve, we're going to talk about 3 different ranges. So this kind of goes back to the idea of what factory size was optimal, right? Initially, if I'm increasing my output, I can move to production facilities that allow me to decrease my per unit costs. So we're going to call this initial portion where increasing my production is decreasing my per unit costs or decreasing my long run average total cost. This will be what we call enjoying economies of scale, right? I'm ramping up production, I'm scaling up production, and good things are happening. My per unit costs are going down. Now, I drew it a bit exaggerated here. It's probably a much smaller range of quantities, but there could be an area in the middle where as I'm changing my different production facilities, I'm really getting about the same per unit cost there, right? So we would call this portion our constant return to scale. Doesn't matter if I increase production or not, I'm keeping my per unit costs constant. And then what if I want to continue to increase my output? Well, eventually, we kind of said what will happen. I'll get to these quantities where if I want to increase my output, I'm leading to higher and higher levels of per unit costs. So here we would say this is going to be diseconomies of scale. If I scale up production past this point, what am I doing to my per unit costs? I'm just increasing them. So where do I likely want to try to be in the long run? What portion of this long run average total cost curve? probably in that constant returns to scale. Now, like I said, in practice, it's a much smaller range of quantities, right? So there's not as much kind of room for error. But depending on what portion I'm on, if I was over here, what would I want to do to my production? I'd actually want to decrease it, right? This is the idea that if my per unit costs are pretty high, I'm in this huge production facility, and I just got space I'm not using. What do? I move to a smaller space that's cheaper, has adequate room for me, but I'm not paying a lower amount. I've lowered my per unit cost and haven't suffered, right, any level of production. It's still large enough where I can produce the quantity I want to produce. So this is the idea of kind of our long run average total cost curve. Now, we'll kind of dive into this deeper, right? And this is what we'll start with a little bit on Tuesday. But we're going to talk about after the exam. All we're going to do before the final is just talk about different types of markets. So we're going to take these cost structures that we talked about this week, and we're just going to analyze them in various types of markets. So up to this point, we've kind of assumed only that we're looking at perfectly competitive markets. So when I'm saying things like, how much money can you make, can a firm make selling a good, whatever the current price is. Well, in practice, we know that in some industries, some companies have a little more influence over the price than others, right? Or you've probably heard this term, or at least played the board game, right? We have different types of markets that are monopolies, right? We only have like one seller of the good. They can kind of dictate the price, right? So think about an area like Bloomington, like there's only one electric company. You want electric, you have to pay whatever the one electric company in town is charging, right? They kind of have some control over the price. So we'll talk more about these types of markets after the exam leading into the final. We are going to talk about, and I will expect you to know though, we are going to think about different measures of what we call market concentration, right? So we're going to have two real measures that we talk about before this midterm. The one is going to be our 4-firm concentration ratio. Now, we're running a little bit out of time. I'm not going to expect you to know this for the quiz. This is what we'll really make sure we work through more problems on or over on Tuesday, but you will be expected to know this for the exam. All right, so the questions on the quiz won't cover this. Questions on the exam could. So we'll dive deeper into the 4-firm concentration ratio, as well as this, what we call HHI or Herfindahl-Hirschman index. So these will be things that we kind of, I pick up with this on Tuesday's class period. We'll go through this, talk about them, work through a couple problems, see some different examples. They're really easy. I mean, first of all, this 4-firm concentration ratio, it's literally adding up the percent of total sales the top 4 firms have. So all you're going to be doing is looking at what's the number and what's the level of sales the top 4 firms have over the total number of sales in that industry. It's not going to be that complicated, right? So that will be things that we save. I've got a bunch of different markets that we'll kind of talk about. That should be, like I said, about the first 10 minutes of class Tuesday. We'll then kind of start working through some of those problems on that practice exam. So if you have time to look at it, kind of review that, bring those. So we're not quite done. So bring those questions